Experiment number 2 today, and it's about the density.
It's showing that.
Oh, let me switch.
Yeah.
Switch. Yeah, now you can delete the first one. It's the fresh one. Experiment number 2, density. So in this experiment, we'll talk about the density here being a ratio of a mass over the volume at specified what temperature. Specified what temperature. So this is the definition of a density, correct? So this is the definition of the density. So we have, if we can, the density, just to give it the symbol of D. This is a symbol here. And the volume, we'll give it the symbol of V. Correct? And the mass, we'll give it the value of small m. Not the meter, that's just the mass, correct? That's the symbol here. So this ratio here, the density will be D equal mass over volume. This is the general formula. This is what? The general formula here. And out of this general formula, one can make two sub-formulas. One can make what? Two sub-formulas. The two sub-formulas are, it is, the mass will be density multiplied by the volume. That's another sub-formula here. And another sub-formula here is the volume is mass over the density. So we have two sub-formulas from the main general formula. So, and it has to be always given at specified temperature. At what? Specified temperature. And all this calculation, it has to be at specified temperature. It's very important to get the temperature. I mean, we will know in a minute, correct? So, now, the next we have to know what are those units of the density. So this is number 1. We'll have units of the density. So it is units of density. Units of density here. So if we have solids, then the density will be gram over centimeter cube, correct? And I can make it smaller a little bit so you can follow me here. So solids, units of the solids, we use gram per centimeter cube, correct? And for the liquids, we use grams per milliliter, correct? For the gases, we use gram per liter. So you can see those are the different units for the different states of matter. So now, out of this one here, we can conclude that 1 centimeter cube is really equal 1 mole. And this is very important here. Thus you can imagine that you have a cube here. Its dimension 1 centimeter each. You can imagine here and a cube here. And it has 1 centimeter length, 1 centimeter depth, and 1 centimeter height, correct? This is length, this is width, this is height. And the volume of the cube here, volume of the cube equal to height multiplied by length multiplied by width, which is 1 centimeter multiplied by 1 centimeter multiplied by 1 centimeter, which is 1 centimeter cube. Correct? This 1 centimeter cube can be filled exactly with 1 mole, correct? Of H2O. So this 1 centimeter cube, so 1 centimeter cube object can be filled with exact 1 ml of H2O. So the conclusion is 1 centimeter cube is 1 ml. So this is very important. Sometimes for practical purposes we don't have a graduate cylinder, or for some reasons we don't have anything to measure the exact 1 ml. So what will happen here, we say, okay, 1 centimeter cube equal to exact 1 ml, correct? And both are approximate, equal 20 drops, correct? 20 drops by the eyedropper, correct? Or by the pipette, eye pipette, correct? So 20 drops always equal roughly here. This, again, this is what, that's an approximation. It's not really 100%, but it's good approximation. That's 20 drops, we take it as equal to 1 ml. Today we'll learn about, besides this, we'll learn about the density features, correct? So let me write what are the 2 features of the density here, and they are, okay, so density features or characteristics are: 1, we'll take just only 1 or 2. We'll take 2. The first one is very important, and we'll have to prove it inside our lab today. So what is this? This is density is an intensive method of the matter. What does it mean? It means density does not depend on the amount. The density value does not depend on the amount of the matter, correct? So it means density does not depend on the amount of matter. An example of this: 2 drops of H2O, 2 drops of H2O will have the same density here of 25 liters, or say 4 or 5 gallons, correct? Or 5 gallons, so about 6 gallons. So here, so whether you have 6 gallons or 25 liters or 2 drops, the density of H2O remains the same. Does not depend on the amount you are using. So whether you have a large amount or small amount, the density does not change. And this is characteristic for the density, and every physical properties of the matter that's really intensive means does not depend on the amount. And there are a lot of other physical properties, correct? They are not depending on the amount, such as melting point, freezing point. All those type of temperature is not depending on the amount, as well pressure as well. So it does not depend on the amount. So those are independent of the amount. The second one, which is very important as well, characteristic of the density, very sensitive for temperature. And this is you can recognize this just for looking at the definition, is mass over the volume. Mass, M, does not change, correct? Does not change. But what is really changing by temperature? The mass of any matter here will remain constant regardless whatever the temperature is. However, the volume of the matter, the volume of the matter what? The volume of the matter is changing by changing what? By changing the temperature. And this is very important. So this is very important, and you will see that this is very sensitive. The volume is very sensitive, and it's very sensitive for temperature, correct? And you can see always in textbook, densities are given, the values of the densities are given with connected what temperature they are taken, correct? Without temperature, the density has no value. You have to give what temperature is, because this density might be up or down depending on the temperature, because the volume is changing. The mass does not change the temperature, volume does. So that's the reason it's very sensitive, correct? And you can look at some tables of some compounds. The same compound has different densities at the different temperature. So, and therefore today what will happen to the first experiment here, number 4. So what will happen here today, we have to learn and prove to ourselves that the density is an intensive method. The intensive method means we have to prove to ourselves that's really intensive, does not depend on the amount. So the first part of the experiment, so part one of the experiment, prove to yourself and the rest of the class that density is an intensive property of matter. This is the first part we have to do. Now, what you have to do here, you will take first the procedure here, and then I'll show it here, explain it. But let me write the procedure first. The first step here, this is the first step here. You take an empty, correct? Weigh an empty graduated cylinder. Say we have about, say, 100 ml graduate cylinder, correct? You weigh it empty. So you have to weigh this one what? You have to weigh it empty. So this is the graduate cylinder here, and it is empty here. You weigh it empty, correct? Second here, you add to it, exactly here, 10 mL of distilled H2O. Now, in your book, say take tab H2O, but I can tell you there's a little bit of differences between distilled H2O and the tap H2O. Somebody will tell me what's the difference between them? So here, in your procedure here, say take tab H2O. But you said, I'd say take distilled H2O, because distilled H2O what? Does not have what? Ions, correct? Does not have any ions. So the density will be not identical. Distilled H2O and tab H2O might be a little bit different in a density. A little bit, not that much. So, might here, a little bit different in density. Not identical. Okay, now listen. You fill this one here 10 mL, correct? The third step, what? You go and reweigh the filled graduated cylinder. Reweigh the filled graduated what? Cylinder. You go and refill, you filled it with 10 mL, go and reweigh. Correct? Everybody's following? Now, I know the volume of this H2O, distilled volume of the distilled H2O. Volume of distilled H2O is what? 10 moles, correct? And the mass of H2O, here, guys, will be mass of graduate cylinder here, filled, correct, minus mass of graduate cylinder empty. So can you see that? So that's what gives me the mass. The density then, the density is mass, correct, which is here, of H2O divided by the volume H2O. The volume, you know, that is 10 moles. We will put always the time, we'll have it at least in a 3 significant figure, correct? So we'll put 10.0 ml, 3 significant figure, always 6 fix 3, so for precision purposes. And here is the mass from this, here it is, the mass itself, correct? So this is the mass of what? 10 moles. Everybody's following? This is the first part. Part 2, I will be using the same graduate cylinder filled with 10 moles. I will add another 10 moles to it. I will add what? Another 10 moles to it. So I will add what? Another 10 moles to it. So here it is. And this is 5. Part 2. Use the same filled graduated cylinder with the 10 moles, correct? Add to it another what? Another 10 moles. Another 10 moles, correct? So that the total volume is 20 moles, correct? So now we have 10 moles and 20 moles. 10 and 20 moles, correct? So you added another 10, the total is 20 moles. Now you go and subtract, we know the volume, so volume of H2O. Volume of H2O now is how much? Is 20 moles, correct? The mass of H2O will be mass of graduate cylinder filled with, correct, with the 20 moles minus mass of empty what? Graduate cylinder. So, okay guys, and then you do the density here, mass over the 20.0 moles, that will give you the density of H2O part 2. This is part 2. So, if you have done very good, part 1, density has to equal what? Part 2, density. See here? The 10 moles here, this is for the 10 moles, has to equal what? The 20 moles density. That's what it says. If we have done very good job, and it has to be 10 moles, 20 moles. So now we have a reference for this. At room temperature like this, the density of H2O will be around what? 1, correct? So at room temperature, okay, as well as at 4 degrees, 4 degrees Celsius, the density of H2O, is 1.00 gram per ml. See, 1.00 gram per ml, correct? So, everybody's following? So now we know that's a proof for us that the density is what? An intensive property of the matter of H2O, of any matter. So now, if you get something that are not equal, then something wrong with your procedure. So if they are not equal, there's something wrong with your procedure. Weighing wrong, reading the graduate cylinder wrong, something wrong with calibration of the balance wrong. So let's write this one here. There is sometimes you'll not get the exact one. So number 6 one here. If part 1 density is not equal part 2, then we have, if they are not equal, then we have a problem where then we have something, there's an error, correct? Errors there. So the error is maybe weighing and then reading graduate cylinder and or, so weighing, reading graduate cylinder and or balance calibration is not, so balance calibration problems. So you have all those 3 problems, and that's the reason you get them not equal. So you might have to repeat. So you have to repeat repeat one part till the 2 parts of procedures are equal to each other. Okay, guys. So this is the first of the whole thing. Now, in the past we did the specific gravity, but this time we will not do specific gravity. But at least we have to know what specific gravity is. That's not in the experiment, so is not part of the procedure, but you have to know how to calculate this one in the quiz or in the exam, the quiz of the lab or the quiz in your lecture. So specific gravity. So specific gravity is defined as a ratio between 2 densities, correct? So between 2 densities. The first density is density of the matter in question, correct? And the second one, density. Please don't talk. If don't force me, I'll kick you out. I'm telling you, please. People like trying to explain to you everything, but you are talking. It's no respect. Both of you, I'll kick you out. You both. Last warning. Out. Because you're on this lab. Show some respect, okay? So, back to this. Density of the matter in question over the density of the reference. So here it is. Specific gravity is given as SG, the specific gravity here. As I said, we'll not do the experiment for it because the equipment is not there. Specific gravity here is given as 2 densities. Density of the matter, correct, of the compound in gram per ml, correct, in gram per ml, divided by density of H2O in gram per ml. And it looks like, if you look like this, the gram per mole with gram per mole cancels out. Gram per mole with gram per mole cancels out. Correct? So now, the density of H2O at 4 degrees, at 4 degrees Celsius. At what? 4 degrees Celsius. So this one here, as I said, I'll scan those for you guys, so don't worry about rushing, writing. I'll scan those for you, then you can see them. That's a 6. 7 here. If you look at the specific gravity is defined as density of the compound, correct? Gram per mole divided by 1.00 gram per mole. This is the density of H2O at 4 degrees. This is what? Density of H2O as a reference. Density of H2O at 4 degrees Celsius. This is our reference, correct? So now it's unique about this, the gram with the gram cancels out, and the Sg is nothing less than just the density of the compound, without unit. Without what? Unit. It does not have without unit. So without unit. So that's the specific gravity. And I can assure you about one question or two in this coming quiz you will take. So that's specific gravity. We cover it. So there's no use. So we cover this one here. So this is specific gravity. The second part of the experiment is determination density of a metal, correct? So determination, the second or the third part of the experiment, the third part here. Determination of density of a metal, and this metal here, it is what? It's a cylinder shape or cylindrical shape. It has a cylindrical shape, so a cylinder, correct? So this is the last part of the experiment, correct? And if you look at this, we'll have to do it two ways, two methods here. So here it is, and here it is. The first one is direct. The first one here, direct measurements, correct? Direct measurements method. And the second one called displacement method. So, correct guys? Two methods. Let's go for first the direct measurements. Let's go for the direct measurements here. And if you look like this, the first method here is direct measurement. Now you can see we have to use a ruler here, and this is our cylinder here, different type of cylinders, so you can see them here. This is, you can see them here. And what's your intuition will tell you about this metals here. So this one, what do you think the first one can be? Your feeling will be. See, very light, correct? So that's the density of this compound here. And this is, what can be this one here? What's your feeling will tell you? That's light too. This one is heavy. So if you look at those cylinder here, the direct measurements is straightforward. We have to measure, but it has a lot of error though, correct? So this is aluminum, this is brass, and this is copper. And we have about zinc, maybe the other one, there's other metals. And we have brass, that's a brass, that's aluminum, that's copper. And we have zinc and lead. So, but if you take one of them here, you have to look at your values you are getting and make an error. So here it is. Those values are given to you here somewhere. Just hold on, I'm just looking for the for the table. If you look at the table here, I'll switch to show you the table here. Let's look at the table here, and let's look at the table here. Just show you the table. Let's look at the table here, and then you can get those tables here. Can you see them? Those are the tables. That's your absolute value, correct? So those are your absolute value. And then you have to make a calculation. You make your error, so how far or how close you are for average of both methods. You can take average of both methods and see how far or one method, see how far or how good your method is to the absolute values in your right. If you look at this, aluminum, whatever. So brass might be not in, but we can Google it for you. That's no problem. A brass is a mixture of zinc and copper, mostly copper, 80%, and 20% zinc. But the percentage between them, they're really different. Sometimes 70 to 30, 75 to 25, 80 to 20. But the normal brass, 80 to 20. So 80% copper, and 20% switch here, 80% zinc. So let's look at here, direct measurement. So what I will do here in this, I will come here and then start measuring the dimensions. So here it is. This is, I view this cylinder here. The cylinder can be vertically here, correct? That's a vertical view. Or I can view it what? Horizontal.